Here in lesson 3, we're taking a break from big long story problems and we're just kind of freshening up on our ability to work with complex numbers. And so remember, complex numbers usually have an I in them, and so we'll be reviewing that. So, learning target number 4, be able to perform operations, add, subtract, multiply, divide with complex numbers. All right, so here we are back in the world of taking the square root of a negative number. We know that realistically we can't do that. There is no number that we can multiply by itself to give us negative 16. However, what we can do is, well, we can split this up. We can say that this is the same thing as the square root of negative 1 times the square root of 16. We can take the square root of 16. We know that that is 4. And then kind of what we have done is we've just kind of made this imaginary number. We know, or at least we have just said, that the square root of negative 1 is going to be equal to the letter I, standing for one imaginary number. And so here we have the square root of negative 1, so we'll just say that this is 4I. All right. And in essence, I just kind of works like any other letter, X, Y, T, when we operate on it, but we do know that I stands for the square root of negative 1 in the end. All right, here with the square root of 70. Again, I can kind of pull this apart and I can say, all right, well, this is the square root of negative 1 times the square root of 70. Well, are there any friendly factors? Are there any square factors to 70 that we could take the exact square root of? 10 and 7? No. 35 and 2? No. None of those are going to help me, and so I can just say I, and then, well, the square root of 70 is simplified as much as it can go. So it's okay if I have this imaginary number times another radical. Okay, over here, I've got the square root of negative 48. Well, I can break this one down even a little bit more. I can say that this is the square root of negative 1 times the square root of 48. But the square root of 48, I know, is the square root of 16 times 3. I can find a friendly factor, a factor with a square number, 16. And so I'll start reducing this down. The square root of negative 1 we know is I. The square root of 16 is 4. And then the square root of 3, well, I can't do anything with that, so I just leave it the square root of 3. Just so you know, the final answer is usually written in the form with the coefficient first, and then the I, and then the radical last. All right, so 4I radical 3, and we're ready to go. Okay, so just kind of getting ever more complex today. Here I have the square root of negative 7 times the square root of negative 7. The way I'm going to pull this out is kind of like treat each one individually. I have the square root of negative 1 times the square root of 7, and then times another square root of negative 1 times the square root of 7. Well, here's kind of what happens. You can think of it in a couple different ways. The square root of negative 1 times the square root of negative 1. If I were to kind of put this back together, it'd be a little bit like saying the square root of negative 1 squared, in which case you just get negative 1. Or I could think of it as I times I, which would just be I squared. And so because we kind of know that this would wind up giving us the square root of negative 1, we know that we know that I squared would just wind up being negative 1. It kind of takes the imaginary part out of it, which is a nice thing. And then kind of finishing off the other part, I've got the square root of 7 times the square root of 7, which would just be the same thing as the square root of 7 squared, and that kind of cancels these things out. And which means I'd have just 7. So I wind up with negative 1 times 7, which is just negative 7. La-ti-da. All right, let's see what happens when I don't have exactly the same number. And just so you know, it is not a coincidence that negative 7 being our answer is the same thing that we see underneath there. All right, but here they are not the same number, and so what we're going to do, again, we can kind of pull this all apart. We can say square root of negative 1 times the square root of 6, and then times the square root of negative 1 times the square root of 10. Well, again, I can kind of piece together this stuff here. The square root of negative 1 squared is going to be negative 1, or it'd be like I times I, which is I squared, which is negative 1. So I've got a negative 1 here. And then, well, the square root of 6 times the square root of 10 would be the square root of 60. Are there any square factors, any friendly factors that I can pull out of this? Well, I think that there is. We can go ahead and say that this is the square root of 4 times the square root of 15, which would leave me with negative 1 times 2 times the square root of 15, or, in other words, negative 2 times the square root of 15. And we're done. That's been simplified. All right, this one, if this one kind of sends chills down your spine because it looks like a little something familiar from a bad dream, if you had bad dreams about the quadratic formula, that's what this is kind of representing. And so, yeah, what happens when you hit that that discriminant that's a negative? Well, it means that there are no real solutions. But if you've passed Algebra 2, then you know, well, you can still kind of find some answers. And so let's go through the process of what this would look like. We've got 8 plus the square root of negative 1 times the square root of 128. And take all of this and divide it by 4. Well, I think the next step is to see if there are any friendly factors to 128, and I do believe that there are. There's actually quite a few. So we'll turn this square root of negative 1 into I, and the square root of 128, well, that could be the square root of 64 times the square root of 2, which is going to be the most efficient route here to this. All right, so just kind of keep plowing along. We've got 8 plus the square root of 64 is going to be 8. So this is going to be 8i times the square root of 2 divided by 4. And remember, I can't just like divide this one by 4. I've got to divide both of these terms by 4. So it's kind of like saying I'd have 8 divided by 4 plus 8i radical 2 divided by 4. And remember what I said earlier, that you can kind of treat this like it was any regular variable. Like 8x divided by 4 would just be 2x. So in the end, I've got 8 divided by 4, which is 2, and then 8i divided by 4, which would be 2i. And then, of course, the square root of 2. And we're done. All right, moving on. Here we've got kind of some things that look familiar. You know, if I just had x's here, this wouldn't be a very scary problem. The i's give it that extra level of intensity, but it's really not that bad. I'm just going to combine like terms. I've got negative 4 minus 6, which would be negative 10. And then I've got 3i minus negative 7i, which would be like 3 plus 7, which would be 10 plus 10i. And, well, that's about all we can do with that problem. We're done. Yeah. All right, over here. Again, we're going to treat I like it was kind of a regular thing until we see something otherwise. So you know, this is kind of like one of those standard FOIL things. I'm going to take 2 times 3, that's 6. 2 times 4i, that would be positive 8i. And then over here, I've got negative 3i times 3. That would be negative 9i. And then negative 3i times 4i. Well, that would be negative 12i squared. So combining some like terms, I've got 6. 8 minus 9 is negative 1. So negative negative I, negative 1i. Let's see, and then minus 12i squared. Well, we know that I squared is the same thing as, sorry, let's see, 2 times 3. And so we know that I squared is the same thing as -1, so we got minus 12 times -1. All right, let's see. So at this point, I can do a little bit more simplifying. So 6 minus I, -12 times -1 is going to be positive 12, so plus 12 here. And I wind up with 18 minus I. And that's it. Okay, on to our last slide. We've got a few more just kind of special examples here. You might look at this. Well, it looks kind of just like the last one, except that what we're going to be able to say here is, well, this is kind of like a difference of squares, isn't it? So if you kind of prepped yourself for the SATs, you recognize that right away. But if we kind of do the long way here, we notice something a little strange, a little something different. We do get 6 times 6 is 36. And then we get minus 30i and plus 30i. But then here at the very end, we get minus 25i squared. And so, yep, the negative 30i and the positive 30i cancel out just like they did with difference of squares things. So we have 36 minus 25i squared. But we do know is that, well, I squared is -1. So we get 36 plus 25. 25, -25 times -1 being positive 25. So my answer is 61. If you want the shortcut for this one, essentially what this is going to be is it's going to be a squared plus b squared. You take this squared, add it to this squared, and we just wind up getting there. So that's kind of the neat shortcut, and this is the reason why we get that shortcut. All right, now we're going to take this idea of kind of doing the opposite complex number, and we're going to use that to take care of some division with complex numbers. Now normally, if I had like a square root in the denominator, I just multiply by that square root, and that's what would take it away. But here, what I'm going to do is I'm going to use this concept to get rid of my imaginary number in the denominator. I'm going to say 5 plus I on the numerator and the denominator. So it's still just like multiplying by 1. In the numerator, I wind up with just kind of another example of the FOIL stuff with the i's. 3 times 5 is 15. 3 times I would be 3i, so plus 3i. And then here I've got 10i, so plus 10i. And then 2i times I would be plus 2i squared. But the magic is really happening down here on the bottom. I've got this case just like I did over here. So if I wanted to take the shortcut, I'd just take 5 squared plus, this would be like 1i, so 1 squared, and that would just be 26. And that I has kind of been taken care of. In the numerator, I'm going to start combining some like terms. I've got 15, and then 3i plus 10i is 13i. And then I squared is -1, so 2 times -1 is -2 over 26. And so again, I've got some more obvious things to combine. I've got 15 minus 2 is 13, so 13 plus 13i divided by 26. Well, I can sort of divide both of these, at least reduce them. And so I'm going to say 13 divided by 26 is 1/2, and then 13i divided by 26 is 1/2 I, or I divided by 2. All right, well, that's it for operations on complex numbers. Thanks for watching.